Alright, for this video here, we're going to be doing 1.7 combinations of functions, and we're also doing compositions of functions. We'll just spend one day on this section. A lot of this is kind of basic review of algebra. If you see right here, the first four properties, these are combinations of functions, and it basically just goes over the four basic operations. Adding for the first one, subtracting for the second one, multiplying, and then dividing. Whenever you see it written like this, okay, f plus g of x, that just means you add f of x and g of x together. That's all. Same thing with subtraction, means you just subtract. Multiplication, you just multiply these together. It's what this little asterisk means multiplication. And here, if you have f over g, well, then that's just the same thing as saying f of x divided by g of x. And one restriction, that g of x can't equal 0, because then it would make it undefined. If, for number 4, if we switched it and said g over f of x, well then f of x couldn't equal 0. You'll see a lot of this is just kind of basic, adding and subtracting like terms and multiplying and dividing. One little thing I have down here that we're going to work with a little bit later, when you combine these functions, sometimes you get a different domain from f and g. And the definition for this, you can take this down right now. When you combine two functions, the new domain, it's just all real numbers that are common. That's the key word. That are common to the domains of f of x and g of x. Think of it this way. Another word for common is intersection. So you basically want to find what values are common for both domains, and that'll give you the new domain. Now, honestly, most of the domains we're going to deal with, they're going to be all real numbers. Before, really only two examples that we looked at where you restrict the domain is when you have a fraction. So that's when we divide two functions, or when we have a square root. And we'll see that a little bit later, I think, on this page. All right, let's move down to the first problem here. Okay, move down to the first problem. We have f and we have g. And for a and b, we would just want to add them. And then b, we want to subtract them. So if we add them for b, well, this is just like saying f of x plus g of x. And you're going to say the only thing you wind up doing here is adding like terms. So f of x is 2x plus 1. G of x is x squared plus 2x minus 1. Okay, I look, the x squared, I can't combine that with anything, so I drop that down. I'm done with it. I cross it out. I look at positive 2x, positive 2x. When we add those, we get 4x. So we're done with the x's. Okay, then we have plus 1 and minus 1. Well, these cancel out. So this is what we end up with here. Now, this is it. You don't have to do anything else. You don't have to pull out an x and factor it. You just want to get what the new function is in terms of x and make sure it's simplified all the way. And it is. You're not solving for x. You're not doing anything else to it. Okay, for b, well, this is just like saying f of x minus g of x. So it's literally the same thing we did for a, except the one thing we have to do is we have to distribute this negative. So let's put, f of x is 2x plus 1. Now, if I'm subtracting that whole quadratic g of x, it's real important we have to put that in parentheses. Didn't matter for the plus because it's like distributing a positive one, which everything stays the same. But here you're going to distribute a negative 1, so let's put the x squared plus 2x minus 1. So when you distribute that negative, well, the 2x plus 1 I can bring down. You distribute the negative, then it becomes minus x squared minus 2x, and that negative 1 changes to a plus 1. Okay, same thing, the x squared, I can't change anything to it, except now it's a negative x squared, so I'm done with that. Now the x's cancel out, because you have 2x and negative 2x. They're opposites, so they go away. But now the 1's, they don't cancel out. You have a positive 1, another positive 1, add those together, and you get plus 2. So negative x squared plus 2, those are unlike terms, so you're done. So pretty easy, pretty straightforward there. Okay, let's go to 2. 2, we have two different functions. And actually, number 1 and number 2, all of these, the domain's all real numbers, so it's really not going to affect the domain when we do f plus g and f minus g. All right, for a, let's do multiplication. Let's multiply these out. Now, when I multiply these out, it's important to put x plus 5 in parentheses. And we'll times this, put a little dot there for multiplication. So really all you're doing is distributing the 3x. So you distribute the 3x to x, you get 3x squared. 3x, so this is what I'll put the arrows there. And then 3x times that 5 is plus 15x. Can't combine those. You're not solving for x. Just leave it like that. Okay, now this is a little bit different. For b, it says f plus g of 2. Well, if you look, normally, you see here what I'm highlighting, normally we have x. Well, what this means is we're replacing that x with 2. So what this means is we're going to take the function of 2 plus g of 2. So we're just going to substitute x equals 2 in for f and g. So when we substitute, let's see here, f of 2, well, that just becomes 2 plus 5. And that gives us 7. And then when we put 2 in for g of x, well, that's 3 times 2, which is 6. So then I just bring down this. So it's 7 plus 6, which equals 13. So this is the only case when you do any of the combination of these functions when you get out a number, because we're putting in a number. So think of it this way. I put in 2, so I get out a number. All these other ones, I put an x, so I get x's back. All right, let's kind of get into that, what I was talking about, that domain there. Okay, when I do this, the domain, well, let's first do this. It's real easy to do f over g and g over f. The main thing is talking about the domain. Let's see here, okay? If I talk about the domain, let's look at square root of x. Oops. If I look at square root of x, remember we can only take the square root of 0 and positive numbers. So the domain for f of x is greater than or equal to 0. Pretty easy. For g of x, let's do this in a different color. This is going to take a little bit of work because we don't just have x in the square root. We have 4 minus x squared. So let's do this. G of x, we'll put in Seneca green right there. Okay, now this whole quantity, 4 minus x squared, that has to be greater than or equal to 0. Right, because you can't take the square root of negatives. If we added x squared to both sides, we have 4 is greater than or equal to x squared. I'm just going to switch it around so I have x squared first, so it's x squared is less than or equal to 4. Okay, if we take the square root, we get x, and then square root of 4, since we're doing it to both sides, remember it's plus or minus 2. And when you have that, for the positive, you keep the same symbol. I think we did this before. I think it was back in section 1.4. So you have x is less than or equal to 2, or then we flip it around for the negative. X is greater than or equal to negative 2. Now, if we put this in interval notation, this is just going from negative 2 to 2. Right? I can't put 3 into this. Because think, look, if I put 3 into this, 3 squared is 9. 4 minus 9 gives you negative 5. You can't take the square root of it. You can't put values in that are less than negative 2. If you put a negative 3 here, you get the same thing. Negative 3 squared is 9. 4 minus 9 gives you a negative. So if I want to find the domain of this function, well, actually, you know what? Let's just leave it like this. Okay, that's the domain for g. This was the domain for f. Now let's do what f over g is. So I'm just going to slide it over here. So we're going to have, let's see here, f over g. Well, I just leave it as square root of x over square root of 4 minus x squared. Now, when I find the domain, let's do the ending domain in a different color. Let's do it in red. So whatever's in red, this is going to be the answer for this, for the domain of f over g. So when we do that, okay, when we do this domain right here, now what's common, if you actually graph, I'm going to graph this. Okay, x is greater than or equal to 0. This is a closed circle, and you go to the right. Okay, then if I graph this here, this negative 2 to 2, well, I say this is negative 2. I say this is 2. And these are both included. Where you can look, the key word was common, or where they intersect. This is where they intersect, 0 to 2. So that's going to be our domain. Now the only thing here is, if you look at the bottom, x can't equal 2 because it's going to give you 0 in the bottom. So we're going to say our domain, we're going to go from 0 to 2, but I can't include 2 because that'll give me 0 right here in the bottom. So this is your domain here. All right. Okay, I'm going to erase this and then do the next one. And it's pretty much, you're going to get the same thing, except there's going to be a little difference when we flip it. So I'm going to erase a lot of this right here. So if you didn't get it, you can pause it and make sure you take everything down now. Okay, so I guess I can only get rid of everything in the green. Well, actually in the red. Let's see here. Let's see if I can get rid of this in the green. No, I can't. All right, well, I'll squeeze this in. I'm going to do B all the way down here. Okay, I'm going to do G over F. So when I do G over F, okay, let's do this in red again. Okay, when I do G over F, apologize for this getting a little sloppy here. When we do this, it's just flipped. It's just square root of 4 minus x squared over the square root of x. And your domain, it's going to be, I'm going to put 0 to 2. It's got to be that because that's where it intersects. But now x can't equal 0 in the bottom because you can't divide by 0. So now it switches. This, we put parentheses because it can't equal. Here, we put brackets around the 2. All right, I guess that can be a little bit confusing there. Okay, and if you go to the back side of the notes, I'm not going to do everything. All I'm going to do is just give you the definition for the composition of functions. This is where we say FOG or GOF. What this means is basically here you're putting in G into F. So this just means it's the function of G of X. So you take G of X and put it into X for that function of X. Here it's the opposite. I'm going to take F and plug it into, or substitute it into G of X. So this notation is G of function of X. All right, so we're going to do the rest of this page in class tomorrow, and probably still do a little bit more of the combinations of functions.